Moving along, we're going to look at lesson 4.8, which concerns combinations. And we're going to use this Wendy's scenario. So a few years back, Wendy's had a takeout bag which said there are 256 ways to personalize a Wendy's hamburger. Luckily, someone was paying attention in math class. Is this correct? The 256 ways. So we're going to explore that, and along the way we're going to pick up this idea of combinations. So Wendy's offers 9 topping options for their hamburgers. Mr. Wilcox wants 3 toppings. How many possible ways can he choose 3 toppings if the order matters? All right? If order matters, then this is definitely permutations. All right, so as we normally do this, for the first topping, he has 9 choices. Once he uses up one of those, he's got 8 left for the second choice. And using up those 2 leaves him with 7 for the third choice of topping. And that's all he's getting. So 9 times 8 times 7 is 504, which is an amazing amount of ways to get 3 toppings from 9 choices. All right, and this is permutations. So then you remember the notation. That's 9 P3, or 9 things taken 3 at a time where order matters, and that's also 504 because we've already calculated that. And in a permutation, order matters. All right, and Mr. Wilcox then, for number 2, decides on ketchup, mustard, and onions on his hamburger. List out all the possible ways you can put these toppings in order. Okay, so I'm going to start with ketchup. And then just, onions and mustard. And then I'm going to start with ketchup again and just switch those 2. So mustard and onions. So starting with ketchup, that's as far as it goes. So the next thing I'm going to do is start with mustard. Follow that with ketchup and onions, and I can do mustard a second time and then switch those 2 to get onions and ketchup in that order. So the last thing that we can use to start with will be onions, and we can have ketchup and mustard after that, or onions and switch those around, mustard and ketchup. And so this will be 3 for the first choice times 2 for the second choice times 1 for the third. And that's going to give us 6. Well, this is it's going to be 6 different choices of the same thing, basically, which is again 3 factorial. And you can also see this as being 3 things chosen 3 at a time where order matters. Okay, so does the order of the toppings matter? In other words, if you go in, are you ever, just determined to get the ketchup first and then the onions and then the mustard? Or would any of these work? Because they basically end up all in the same place, right? So I'm going to say that it doesn't matter. And they use, for example, is ketchup then mustard the same as mustard and then ketchup? And if you look at that, these 2 burgers would taste exactly the same. All right, so the fact that they taste exactly the same kind of makes them into the same thing. So what's happening when we do permutations is we get a lot of duplication. And I don't mean that you're getting the same thing, the same orderings, but in many cases or in many circumstances, the order of what you choose really doesn't matter. And if you use permutations, you're going to get a lot of duplicates for the same group, just in a different order. So how many ways can a person order a hamburger from Wendy's with 3 toppings if the order of toppings does not matter. Okay, if this ordering does not matter, we're not doing permutations anymore. We are doing combinations. And in combinations, order doesn't matter. So if you read a problem and they mention something about how things are arranged, how things are organized, if they want you to pick a group of 3 to fill like a president role, a vice president role, and a secretary role, then whoever goes in those roles matters. But if you're just picking any 3 out of a group of, say, 10, then all those extra arrangements don't matter. Bob, Sue, and John would be the same as Sue, John, and Bob, or any other arrangement of that. So we want to use combinations to kind of eliminate all of that extra duplication. So let's go for it. So we have 9 toppings, and we're going to pick 3. So 9 toppings, pick 3. All right, so we have 9 choices for the first, we have 8 choices for the second, and 7 for the third. Now this is looking a lot like permutations. In fact, it is. But we're going to add a denominator to this of 3 factorial. And so the 3 factorial is going to eliminate the repeats. So eliminate repeats. And we will end up only with, certain groups with certain things in them without the extra duplication. Now we can look a little closer at this, and this is going to be 9 things taken 3 at a time using permutations over 3 factorial, 3 times 2 times 1. And now we can change this into combinations notation, which looks a lot like permutations. It's just 9 things taken 3 at a time, only in combinations. And by the way, that's going to equal 84. Now compare that to the 504 up here, and that took away a lot of the duplication. In fact, took all of it away. Okay, that's combinations, and that's how it works. What we're going to do is we're going to fill in the table here, and we're going to figure out the total number of ways that we can order a hamburger, and we're going to do it using this table. We need to find the number of ways to order 1 topping, 0 toppings, 2 toppings, all the way up to 9 toppings. So we'll start with that. And by the way, just by the way, this is not earth-shatteringly important, but it's something that could show up, and I just want you to know that you've seen it before. So 1 factorial, I asked the group, what did that equal? And they correctly said 1. So then I said, what's 0 factorial? And they incorrectly said 0. This, by definition, is also 1, because using the formula that I just did up here, this formula right here, we could end up with 0 factorial in the denominator, which would make it go, well, if it's equal to 1, then that's fine. But if it equaled 0, then it would be undefined, and that would throw everything into a tizzy. So let's start. Number of toppings are 0. You're just getting a plain burger. So this is going to be 9 things taken 0 at a time. How many ways can you get a plain hamburger? That's going to equal 1. And mathematically, this is 1 factorial over 0 factorial, which is also 1. Okay, just FYI, it's 1 over 1 based on this. So that's 1. All right, so for 1 topping, this will be 9 toppings taken 1 at a time. All right, that's going to equal 9 over 1 factorial. Okay, the denominator is going to be the k, the 1 here, the 0 here, and so on. It's just going to be that number as a factorial. Well, this is going to equal 9. Okay, and then if we want 2 toppings, that'll be 9 choices taken 2 at a time in combinations. So that'll be 9 times 8. That's the permutation divided by this value as the k value as a factorial. So that's 72 divided by 2 times 1. 72 divided by 2 is 36. Okay, I'm going to do one more, and then I'm just going to complete this while you are not waiting. So this is for 3 toppings, 9 toppings taken 3 at a time. This will be 9 times 8 times 7 over 3 factorial. See, that matches. And that's going to equal 84. So here are the rest. So we filled out the table, and you can pause to copy it down if you want to. It turned out that we had 1 up to 126, and then 126 back down to 1 with using the same numbers. There's a certain symmetry to it. And when you add up all of those ways to order, you get 512, which does not compare well to 256 as they put on all their to-go bags. So they did some poor math. But the point is this is how you use the formula for combinations. So let's go ahead and turn over. Okay, we'll start with the learning target. So learning target number 1 is to just go ahead and compute combinations like we did on the front. So this is just the number of ways you can choose a group when order doesn't matter. And just so that we can get all the math symbolism and everything, this is n, c, k, and that's going to equal, that's n things taken k at a time in combinations. So this will be a fraction. Remember, it's the similar permutation in the numerator. So n pk over k factorial. And so remember that n is the total number of items. I guess total only has one L. Get that squared away. Total number of items. And k is going to be the number of items you pick. Number of items that you pick. Okay, now the other two we haven't really looked at yet. And this is going to be what's going to be sort of a complicating factor for what we're doing. We're going to use combinations to find the total number of outcomes for an event and then convert it into a probability. So we're going to just take what we get from calculating a combination, which is just a number, and that'll either be our denominator or our numerator. It may be that we'll have to find both of them in order to create a fraction that we can reduce to a probability or convert to a percent or whatever. And then we're actually going to use this multiplication counting principle in order to kind of chain different combinations together. So the lesson app below here is actually really, really good. So kind of really hone in on what we do here. All right, so number 1 and number 2, number 1 and number 2 will be learning target number 1, both of those. All right, so how many different sets of 8 songs are, well, let's read the scenario. Janine wants to set up a playlist with 8 songs on her phone. She has 50 songs to choose from, including 15 songs by Taylor Swift. Janine's device won't allow any song to appear more than once in the playlist. How many different, this is number 1, sets of 8 songs are possible for Janine's playlist? Assume that the order of the song doesn't matter. So if it doesn't matter, this is definitely combinations. Okay, and the kind of combination we have, there are 50 songs, and they're going to be taken 8 at a time. All right, so just think about it this way. The first choice, there are 50 available to pick from. And then when you pick one, you're down to 49. And we need 8 of those numbers to be multiplied. So times 48 times 47 times 46. And that's going to go all the way down to 43. And that'll be over 8 factorial. This number as a factorial, which I am going to write out expanded. 8 times 7 times 6 times 5 times, times 4 times 3 times 2 times 1. All right, that is 8 factorial. And we're going to get a stupendously large number. This will be 536,878,650. So yeah, she's got a lot of ways to build an 8-song playlist. So this is going to be that many different 8-song playlists. Okay, hopefully you're not seeing that this is going to be too bad. Yes, the numbers got big, but this isn't 1952. You don't have to do this by hand or with a slide rule. You have a calculator, just put numbers in carefully, hit enter, get your answer. All right, so moving on to number 2, how many 8-song playlists contain no songs by Taylor Swift? Well, there are 15 songs on the device by Taylor Swift. I'm just going to abbreviate to save the writing. So there are 50 minus those 15, because we can't use those, equals 35 songs that are not by Taylor Swift. And again, TS. All right, so this kind of in a way shrinks down the available pool of songs. It's not really that complicated. We're just going to go from 50, where we kind of started up here, down to 35. So this will be a combination of 35 things taken 8 at a time instead of 50 things taken 8 at a time. So it's very, very similar, just that n changed from 50 to 35. So we need 8 numbers starting at 35 choices for the first, times 34 for the second, and so on. And this will take us down to 28. So times 32, times 31, times 30, times 29, and then finally times 28. 1, 2, 3, 4, 5, 6, 7, 8. And that again will be over 8 factorial. So this will be 8 times 7 times 6 times 5. You know the drill. Okay, since we pulled out the Taylor Swift songs, there should be less of these combinations. And there are. It turns out instead of 536 million or so, it'll be 23,535,820. And this will be different 8-song playlists. So 8-song playlists with no Taylor Swift song. Okay, so that was no harder than the first one. So suppose, and we'll call this learning target number 2. Suppose Janine decides to let her phone select an 8-song playlist at random. What is the probability that none of the 8 songs is by Taylor Swift? Now this is a probability. None of the 2 answers we previously got were probabilities. They're just counts of things. But now we've got to convert things into a probability. So the probability of no songs by Taylor Swift and again, I'm just abbreviating to save time. This is going to equal, okay, a fraction because it's going to end up being success over total. Number of 8 song playlists with no Taylor Swift. And that's going to be out of the total number of 8 song playlists. Sorry, you have to wait through this writing. All right, we know those two numbers. This is success over total. All right, we're looking at this. These are the playlists with no Taylor Swift. That would be your numerator. So 23,535,820. And that'll be out of the total up here, 536,878,650, which will give you 0.044. So around 4 or 5% of all the possible playlists will have no Taylor Swift songs on them. Interesting. So if you get question like number 3, it may be sort of set up to be 1, 2, and 3 together in one question. So that shouldn't be the roughest thing in the world. You just have to get the total and then get the count for whatever that particular condition is, and then set it up with success over total. All right, I'm going to put a little star on number 4. This is learning target number 3. Okay, and I changed it to red because this is kind of red alert. Red alert, red alert. It says find the probability that exactly 2 of the songs on the playlist are by Taylor Swift. Now what we're going to do is set up like a how can we say this? It's going to be like a multiplication counting principle where one thing we're going to multiply are just the Taylor Swift songs, and we're going to multiply that to the rest of the artists. All right. So if you're looking at exactly 2 of the songs by Taylor Swift, this will be 15 choices taken 2 at a time. That's for Taylor Swift. All right. But that's not all the songs because these are an 8-song playlist. We need 6 more songs. Well, we've already grabbed 15 out of the 50, so the remainder is 35. Fix that number up. 35, and we want to take them 6 at a time, right? So these would be like non-Taylor Swift. Okay? And so it's going to be that and that, Taylor Swift and not Taylor Swift. And if you look at the 15 and 35, that adds up to 50. And if you look at the 2 and the 6, that adds up to 8. And it looks an awful lot like this, only broken down into Taylor Swift and non-Taylor Swift. All right, so let's go ahead and put these into numbers. All right, so for the Taylor Swift over here, we'll start with that. It'll be 15 times 14, okay? That's the permutations. There's 15 choices for the first, 14 for the second, and that'll be over this factorial, 2 factorial. And then we'll take this combination, and that will be, write it as a permutation, 35 starts the list of products. So 35 times 34 times 33 times 32, we need 6 of those numbers, so we're short 2, times 31 times 30, and that'll be over 6 factorial. And when you get done with all of that and put it into your calculator, it'll be 170,431,800. And this will be ways to get exactly 2 of the songs in each playlist by Taylor Swift. But that's really not the answer. This is not what they asked us. It's a means to an end, but it's not the answer. They want to know the probability that exactly 2 of the songs are on the playlist are by Taylor Swift. So, probability of exactly 2 let's just say we'll go back on that because I think I just started out wrong. No, that's right. Exactly 2 songs by Taylor Swift all right, that's going to be the number of 8-song playlists sorry about wading through the writing again with exactly 2 songs by Taylor Swift. And that's going to be out of the total number of 8-song playlists. And we know those 2 numbers. This top, the numerator, is what we figured out there. That'll be the 170,431,800. And the other number is the one we started with way up here. That's this, which is the total number of playlists. So the denominator will be 536,878,650. And when you get all through with that, you get 0.137, a little less than 14%. So there is a 0.317 probability that a randomly selected playlist will have 2 songs by Taylor Swift. And that is what we learned. Sorry about all the writing and everything, but definitely work the sapling and you will get to be an expert before you know it. So thanks for watching.